Okay, so now if you look at the one on the left and the one on the right, you tell me which one is more easy and intuitive. And it can parse about 5,000 files in 700 milliseconds. Hi everyone, Greg here. So I created my own JSON parser. What you're looking at here now is the RFC file for JSON. So this describes the specification. It is basically a full description of what JSON is, how it works, and what a JSON parser should comply with. Now, the thing that struck me when I read this is exactly how bad a standard JSON actually is. This is really horrible, and I wouldn't recommend that you use it if you can avoid it. So you might wondering, well, why then did I bother writing my own parser since I think it's such a bad standard? Well, the key is if you can avoid it, because, well, JSON basically is ubiquitous today. You look left and you look right as a computer programmer and you're going to come across somewhere. So many different APIs output in JSON, and so it's really hard to avoid. So here we have an example. We have ipinfo.io, and this is used for IP tracking. I am seriously considering using this API for my own website. And so basically what that would be is if somebody visits my website, I can look at the IP address and then I can get a reasonable idea as to where that person is located in the world. Now, IP tracking is not foolproof, but it generally gives you a fairly good idea. Now, if you want to use their API, what they do is they output in JSON. So I haven't decided just yet, but this could be the topic of a next video, one that would fit in my CGI and C programming series. Also, I have dabbled with the YouTube API, and there again, it outputs in JSON. So JSON, unfortunately, today is very hard to avoid, whether you like it or not. So I'm going to explain exactly why I think it is such a horrible standard. First of all, let us be clear as to what JSON actually is. So JSON is basically built around those key value pairs. You have the data itself, and then the key is basically the metadata. It tells you what kind of data we're talking about. You can have 0, 1 or more of those key value pairs, and they're surrounded by those curly brackets, and they're called an object. Then besides that, you can also have arrays. Arrays are basically just values as opposed to the key value pairs. A value can be a string, it can be a number, it can be a literal. So the literals are true, false, and null. A value can also be an object, or it can also be an array. Right? And so you can nest those things into each other. That fundamentally is what JSON is. And then you also have what I call the degenerate case, where basically it breaks that mold, it breaks that pattern, and you just have a single token that makes up the entire JSON file. So that is a single string, a single number, or a single literal. Okay, so now why am I saying that JSON is such a badly designed standard? Well, if you look at the RFC file here again, it tells us that JSON is designed for data interchange. Well, anytime I see something designed for interchange, I would like to see either beginning and end markers, so you know clearly where the data begins and where it ends, or maybe a header and have the header contain a length that tells you how much data will follow and how much data to expect. The reason for that is that it just gives you more context, and it tells you straight away if something went wrong, if the data got truncated and stuff like that. If you look at the bottom of the file here, it gives you examples of what is valid JSON. So this could be a JSON file, and then here you have the degenerate case where a single token is also valid JSON. You have those literals, true, false, and null. Now imagine you receive a JSON file and it's just the word null. Well, it may not be immediately obvious whether that is the actual file or whether something went wrong. So if you had beginning and end markers, or if you had a header, it would give you more context to try and figure out what actually went wrong. Another problem is that JSON is too flexible. Now you're going to say to me, is flexibility not a good thing? Well, generally yes, but you can have too much of a good thing. So consider the following. This is actually a valid JSON file. Now, what is really a missed opportunity here is there could have been a rule saying that all the keys must be in plain ASCII. Now, the keys is generally what you know. Not strictly always, but generally you know what the keys are, and you're trying to retrieve the data using those keys. So imagine you have a computer game, you have a JSON file containing the stats for a character. You know that the character is going to have certain stats like health and stamina and speed and whatever the case may be, and you're trying to retrieve the values for those in your source code using the keys. And so the keys is what you're actually going to type into the source code. Well, so you type those keys into an editor. Every editor always supports ASCII, so it would have been so much easier to say the key should only be in ASCII. And you might be saying, well, modern editors nowadays, they support emojis, they support all kinds of things. That is true, but two things about that. Number one, it's more convenient to type in ASCII if you have emojis. Now you have to start to copy and paste stuff, and it's just more awkward. It interrupts your workflow. And then the other thing is you never know in what context this is going to have to be used. Maybe you're dealing with a server and you have to access it through a terminal and everything is text-based, and you're not guaranteed that it will be able to display the emojis and all the special characters. So this is really a missed opportunity, and it would have been so much more convenient and so much better if you said all the keys in ASCII, alphanumerical, and then in your values, this is where you have potentially your Unicode, your emojis, and whatever it is that you need. So another example of too much flexibility concerns the arrays. And you read in the RFC file here, it says there's no requirement that the values in an array be of the same type. Basically what that means is JSON doesn't really understand arrays. So when you're dealing with lower level languages like C, the key thing to understand about arrays is that it is contiguous memory. So what that means is that all the elements in the array come one after the other. So if you have a character array, let's say, and you call it str, well, str is the name of the array, but it's also the pointer to the first element in the array. Then you can take the index, you add the index to the name of the array, and that then will point to that element in the array, right? So if the index is 2, and of course you number from 0, so that's the third element, you add 2 to the name of the array, and then that will be pointing to the third element. Which is, by the way, also why you do number it from 0, is so that you have this fast and efficient way of adding the index to the pointer, and then you jump straight to that element. What if you have arrays that have a type bigger than 1 byte? Let's say with integers, they are 4 bytes. Well, what you should do in theory is take the index, you multiply it by 4, and then you add that to the pointer. However, the C compiler will do that for you for free. This is done kind of implicitly behind the scenes, and all you really need to do is you add 2 to the pointer to get straight to the third element. Well, this is an incredibly efficient system, and this allows you to loop through an array very, very quickly simply by incrementing the pointer. And this incredibly fast and efficient way of dealing with a lot of data densely packed in the memory only really works if all the elements are of the same type, and more specifically, they're all of the same size. If you're then going to have an array that doesn't have that requirement and you allow the elements to have any size you want, then there's really no point in using arrays. Now, I do understand that in languages like JavaScript, that's how arrays work. You don't have that same requirement for all the elements in the array to be of the same size. But that's exactly what I reproach those higher level languages, is that they don't really get the point of arrays. And so when you read here at the top, it's a language independent data interchange format. The language independent part, it's not wrong per se, but it does come with the caveat that you're dealing with higher level languages that don't really understand arrays. And if you have the lower level languages with proper arrays, then the arrays as they exist in JSON are really pointless. So what is true for engineering in general is that you're going to have carefully thought through constraints, and if you don't put proper constraints in place, then you have a system that is all over the place, that is very slow and very inefficient, and that's exactly the kind of mess you have with JSON. Pothole markers must be the second worst thing when it comes to this functionality. So the worst dysfunctionality would be simply that nothing happens, the problem doesn't get acknowledged, it doesn't get addressed, and it certainly doesn't get solved. The second worst is when people do acknowledge there is a problem and then leave it at that. Obviously, you would prefer that they simply fill up the potholes, but instead they just acknowledge the problem and leave it at that. So it is just one step above complete dysfunctionality. So the RFC file describing JSON contains a couple of those pothole markers. It basically acknowledges some problems, and then it's the RFC file. It is the official specification. It could have addressed those problems, but for whatever reason, it just decided not to. So for example, where the RFC file says, note, however, that ECMA 404 allows several practices that this specification recommends avoiding in the interest of maximal interoperability. So in other words, it tells you there are two standards and just deal with it. The obvious thing would have been for there to either just be one standard or to decide that one standard should be superior to the other so that if they do contradict, you follow one over the other. But instead, they're just telling you, yeah, okay, there's just two standards. If either document is changed in the future, ECME and the IETF will work together to ensure that the two documents stay aligned through the change. So in other words, it might be a bigger problem in the future, and if it does, we'll deal with it then. Let's just go with the mess and write it. Okay, well, whatever. An implementation may set limits on the size of text that it accepts. Yeah, well, why not set a limit in the standard? I mean, and at the very least set a minimum limit. I mean, you could have said, you know, every compliant parser should allow for sizes of at least so and so. That would have made life so much easier for everybody. And that means if you are a software engineer and you want to make sure that your system is compatible with as many systems as possible, you could have said, okay, every compliant parser will accept sizes of at least so and so. Let's make sure that the output we generate stays within that limit. But no, now instead, as a software designer, your only choice is to just make your files not too big and just hope for the best. An implementation may set limits on the maximum depth of nesting. Again, state a maximum or a minimum that a parser should comply with so that you can guarantee whatever output you produce, whatever JSON file you produce, that every parser will be able, every compliant parser will be able to deal with it. But no, they just decided, yeah, just point out there's a problem there. Let's not deal with it. An implementation may set limits on the range and precision of numbers. There's a very obvious way of dealing with this, and that is to say every JSON parser should at least support the IEEE standard. And the RFC file actually does mention the IEEE 754 standard, but it does merely suggest it. It does not actually impose it. An implementation may set limits on the length and character contents of strings. I have set limitations in my JSON parser, and again, I just went with whatever I thought felt about right, and that's the best I could do. So I have here a nesting limit, and I have a maximum size for any file or buffer of 30 megabyte. If you are not happy with those values, well, you can just change them right there in the header file. Okay, so now we come to the design of the library itself. So how did I design it? I began with designing the API. And I suggest that's what you do every single time. Every time you design a library, you ask yourself the question, what would the library be like if it were already done, if it were perfect, if it were easy and enjoyable to use, and then you just reverse engineer from there. So before I designed the library, I went on the internet for inspiration. At that point, I hadn't committed yet to create my own library, and I found this YouTube video. Now, the YouTube video itself is fine. I am criticizing the library being discussed here, not the video itself. So he's discussing JSON-C, and he is claiming that its functions are so easy and intuitive. And this is the file that he uses as an example in the video, and then this is the code that he presents. Now, I don't know about you, but I certainly wouldn't call this easy and intuitive. I mean, look at all the structs, look at those functions. JSON object get X. I mean, like, this looks like a right old mess. I don't know what's going on here. So I said to myself, if this is the easy and intuitive one, then I definitely need to design my own. And so this is the thing I came up with. Okay, so now if you look at the one on the left and the one on the right, you tell me which one is more easy and intuitive. And when it comes to the one on the right, I don't think you really need any explaining. I think it speaks for itself. And the output of both those pieces of code is quasi-identical. So I can prove to you that my code does essentially the same thing. So let's have a look. So that's the file. This is the code. So I'm going to compile it. And now I run the code, and there you are. Okay, so now you have seen how JSENSE performs with a single file. What about a more complicated file? Well, here I have an example file from GitHub. Now, I don't actually use GitHub, but that doesn't matter for the purpose of this example. This is just a generic example file that GitHub puts out. And so when you look at this, you can clearly tell they did manage in making it more complicated. It's a nonsense file, really. Have an array here and an object, and that's the one object inside the array. So you have other objects nested, but you basically have a single object inside the array. So why bother doing the array? I don't get it, but anyway. So let's say I want to get the name, right? So I want to retrieve the name here, Mona Lisa Octocat. So how would I do this? Well, I need the name. It's within author, and it is within the first element of the array. So here we have another test, basically test program, demonstration program. So I have this, I load this GitHub file here, 0 commit, hold on, where's commit? Yeah, commit. So name within author, within commit, within the array. So 0 commit author name, right? So it will be returned into text, and then you just print out text, and it will say name is so and so. Now here's another file on my Linux system. I have this file called countries.json, and what you see in this file is that you have a lot of special symbols, like all the different names of the countries in different languages. And so, for instance, here where it says República de Angola, so you have this special character here. And when it comes to the JSON specification in the RFC file, I did follow the RFC file very closely, and especially what it says about strings and the escaping of strings. I just want to demonstrate that my program can actually deal with the special characters. So I load this other file here, and then I get a couple of things as a matter of example. What if what you get is a number? Well, in that case, here, this is the longitude within a particular country. Well, GSC get will always return a text. So if what you need is an actual double, then you can do text string to double, and this will be included in the code on the GitLab. And you can convert the text to a double, right? So here the same data is being displayed twice, once as a string and once as a double, right? When you have literals, so true, false, and null, they're treated exactly like strings. I didn't see any point in making a distinction, so they're just treated as if they're strings. And then, of course, there's JSC free. So once you're done with the main struct, make sure that you free it. And in a simple demonstration program like this one, it really wouldn't make any difference. The kernel does free all the memory at the end anyway. But if you're dealing with a bigger, more complicated program, just make sure you free the memory and you don't end up with memory leaks. Okay, so now let me demonstrate the same thing again. So we're just talking about test 2. And now you see what it displays. You see that it deals with the special characters, and you see that it can display the text and the doubles. So the JSENSE library, I believe, is very good. It certainly suits my purposes, and I'm very pleased with it. However, I don't want to give the false impression that it is perfect. It is certainly not, and it has a couple of limitations. One of those limitations is the way that I retrieve the data within JSC get. So that label, it can contain those dots, those full stops, and I use this to kind of descend into different levels. Well, the problem here is that, and this is again an issue with too much flexibility within JSON, is that there's nothing stopping a key from containing a dot, which could potentially lead to ambiguity. I decided to not care about that. I'm not using JSON enough, and I don't care enough about it to really worry about it. And I think it's a good trade-off for the convenience that I get with the way I use JSC get. If ever there's a problem, I cross that bridge when I get there. So I don't think it will be a big issue, but it is something to be aware of if you were to decide to use JSONs for your own project. So what I want to do now is I want to test JSONs, and this is going to be a stress test. So basically I want to see how fast it runs. I want to load and parse as many files as possible as quickly as possible. So in order to do that, I'm going to use the command locate, and this will find every single file on my system which matches a particular pattern. The pattern is going to be star.json. So basically every file which has the file extension .json, it is going to find. So when we run this, you see there's quite a few files there. So I'm going to pipe this to WC for word count, WC-L to count only the lines. And it tells me there's over 5,000 files, okay? I'm going to output this to files.txt. And now I should have a file with all of those different paths. What I'm going to do next is I'm going to run this code. So it is going to take the contents of the file files.txt. It is then going to split that string everywhere where there's a new line. So I'm going to have all those lines with path names to a file. Every single path I'm going to pass on to JSC from file. So this will return either a pointer to the main JSON struct or null. If it returns null, I will increment a counter. If it returns the main struct, then I'm going to free it and then a printf at the end and find out how many times it returned null. So what I'm going to do now is I'm going to compile this, and then I'm going to run this program. I am going to use the time command to see how long it takes to run that command and see how fast it can parse all of those things. Okay? And you see it took 1.3 seconds. Now the thing is, this is not the first time I run this command. Or I should say this application is not the first time I run this application. And the kernel has already buffered a lot of those files. When I run it for the first time, I get a number that is closer to 30 seconds. So 30 seconds the first time, and then every time thereafter, somewhere around 1.3 seconds, when the contents of those files have already been buffered. When I'm not recording with OBS and I shut down everything else on my computer, I've seen times as low as 700 milliseconds, right? And I know some people are going to be curious about this. So what kind of hardware am I using? I have an AMD Ryzen 5 and I have about 16 gig of RAM right? So that's the kind of hardware I have. And it can parse about 5,000 files in 700 milliseconds. The best time I've seen is 700 milliseconds. And if we look at some of the errors, we have stray comma. Let's have a look at this. So that's the path. And then, yeah, okay, so that's the game. Total War Rome Remastered. And for whatever reason, they put a stray comma there at the end. Yeah, okay, I won't even speculate. But, okay, so that's not even valid JSON. So we have a couple of stray commas here. What else have we got? Unknown token, so that's here. Let's see, what kind of file is this? Oh yeah, and what you see here is they use those C style comments, and that's not allowed in JSON, so that's why we have a parsing error. So you see this file calls itself status.json, but the contents don't actually resemble JSON at all. So I don't know what VLC is doing here. But so there are errors being produced because sometimes it's just not a good JSON file. Okay. What I'm going to do now is I'm going to run this again, but instead of using time, I'm going to do valgrind. What valgrind does is it searches for memory leaks. So obviously that's something you don't want. You don't want to waste memory. You want to properly manage your memory in any program, and it's going to take a little bit of time here. Valgrind obviously runs a lot more slowly, but what does it say? All heaps blocks were freed, no leaks were possible. Okay, so you've seen the performance, you've seen the time, you've seen that it doesn't actually have any memory leaks. So those are objective criteria to judge the quality of the parser. Alright, so that is the JSON parser JSENSE, and I hope you enjoyed. I hope you learned something, and if you'd like to have the code, there will be, as always, a link in the description to the GitLab where you can download the code. You can look at it, you can learn from it, and you can use it in your projects if you like. As of the moment of recording, we have 8,027 subscribers, so that's amazing. Thank you very much to all those who did subscribe, and those who haven't already, please like and subscribe and share on social media to spread the word and make more people aware of this channel. So we passed a new milestone, 2 to the power of 10, 1,024 subscribers, and you know what that means. Every time we do this, there is a subscriber special. So next episode, I will continue developing the Dux language, the language which has nothing to do with taking over the world, and I will introduce functions and a proper stack inside the interpreter. So if you'd like to see that, tune in for the next episode, and of course if you subscribe and click the bell, then you will be notified when it comes out. So that's it, thanks for watching, and I'll see you in the next one. Bye bye.